Okay, so the next one we're going to do is still in first order integrated laws. Is we're going to do another problem like this one, but it's going to ask us for something different. All right, so I'm looking at another problem directly from the homework. This one says the decomposition of nitronide in aqueous solution at 25 degrees Celsius, and then it gives us the boring chemical equation: 2H2 NO2 aqueous aerosine N2OG plus H2OL. All right, now like before, those first two lines don't matter at all. We can totally disregard them. So if we move on to the third one, it says this is first order. All right, that's good. We can work with that. That means we want to use this equation, right? Because it says that it's first order. Is first order in NH2NO2, all right, so that's the reactant that we're looking for, with a rate constant of 4.7 times 10 to the negative 5 s negative 1. All right, so just like the last one, we're going to start with what it gave us. And it says the rate constant is 4.7 times 10 to the negative 5. Now, the rate constant is what? What's K, right? We figured that out from the last one. So that means, using our equation, we can start by plugging K in. Now, don't forget this negative sign, all right? So it says the rate constant, which is K, is 4.7 times 10 to the negative 5. All right, let's keep reading. It says if the initial concentration of NH2NO2 is 0.464, the concentration of NH2NO2 will be 0.110 after how many seconds have passed? All right, so if we read that again, we'll find that it gives us the two other things we need to solve this problem. It says if the initial concentration of NH2NO2 is 0.464, all right, so it just gave us the initial concentration, all right, and that goes on the bottom, so 0.464, okay? If the initial concentration is 0.464, the concentration of NH2NO2 will be 0.110, all right? So remember, when it says will be, it's talking about the future, right? And the future is nothing but this final reactant. So it says the concentration will be 0.110. Well, since it gave us a number, we already know what the final concentration is, right? It says it will be the 0.110. So that's what we're trying to get to. This is the final concentration we want. So we can already plug it in as our final number, all right? So it says it's going to be 0.110 after blank seconds have passed. So it didn't give us time like the last one. So we can write this little t. If you remember from the last one, it didn't give us the final concentration, but it did give us the time. But in this one, it gave us the final concentration, but it didn't give us the time. So this time we're solving for time, all right? And the math for this one is even easier. Now that we have all of our equations set up, all we're going to do is we're going to plug it in the calculator just like last time. All right, so the first thing you do for this is you're going to go back to that trusty ln button. You're not going to press second this time. You're just going to press the ln by itself, all right? And it's going to pull up this little ln parentheses, all right? Then you're just going to put in these numbers, just like a fraction, just like you normally would. So the way I do it is I do double parentheses, 0.110, close parentheses, divided by, open parentheses, 0.464, and then double parentheses to close it off, all right? So basically we're telling the calculator we want the ln of this whole thing right here, all right? Then we press enter, and we get negative 1.44, rounded. All right, negative 1.44. Got it? Now, all we need to do to find t is we just divide this by this, all right? So dividing this by this means we're going to put this under, all right? It's going to be 1.44 divided by 4.7 times 10 to the negative fifth. All right, so what that looks like in the calculator is, don't forget the negatives, right? Negative 1.44 divided by negative 4.7 times 10 to the negative fifth, all right? And then close that parentheses, and we get 30,638 seconds for t. And that's your answer. 30,638 seconds. All right? So that's how to do the time ones. Now be careful. Anytime that it gives you a time that's not in seconds, it may ask for hours or minutes. Just make sure you convert that before you do the equation. All right? It could say 2 hours, which would be 60 minutes times 60 seconds, right? Times 2, because it's 2 hours. Or if it gave you minutes, then you would just divide this by 60, right? Because there's 60 seconds to a minute. Anyway, that's pretty self-explanatory.